class. I'm Dr. B, your chemistry teacher. Today, we are going to discuss something concerning adsorption isotherm, and that is a very interesting area of surface and colloid chemistry. So we're going to look at the Langmuir adsorption isotherm. So we're going to look at the Langmuir adsorption isotherm. The Langmuir adsorption isotherm. That is what we are going to be looking at today, the Langmuir adsorption isotherm. But the question now is, what is adsorption? Because we are seeing adsorption isotherm. Before we discuss what adsorption isotherm is, what is adsorption on its own? Do you know that there are two ways by which materials get themselves attached to a particular surface? One is that it's either they attach themselves to the core of that particular surface, or they attach themselves just to the outermost part or the surface of that particular material. Now, if this material attach themselves to the core of this surface, then we classify that as absorption, AB. But if the material decide to attach itself rather to the surface of the other material, we describe that as adsorption. Now let us use a diagram to put up that. Do you know that when we say adsorption, we have this as surface A or material A, and we are having this as material B. Okay. And then when we say absorption, we have this and we are having this as material B inside. Did you see? This is material A, and this is material B. And here this is material A, and this is material B. Do you know that when you take a look at what happens here is that this material that we have here is your absorbent. This material is what you call absorbent. And this material here is what you call your adsorbent. Your adsorbent. Your adsorbent. Your adsorbent. Okay, let's say adsorbent, spell this way. Okay, so you can see that when your adsorbent do not go into the core of your absorbent, you describe that kind of process as what? As adsorption. So it is only at the surface of your adsorbent. But when your absorbent is absorbed into the core of your absorbent, you describe that as absorption. Now I'm sure you know the difference between adsorption AD and absorption AB. Now in this case, it means that you could have something like kerosene and water. Sorry, I wanted to write kerosene and water. Okay, so this is of course your kerosene, your absorbent, and this is your what? Your water, that is your absorbent. In this case, the kerosene particles or molecules are only found at the surface of the water. They are not absorbed to the core of the water, so that is adsorption. But here you could have something like a cube of sugar and water. Now in this case, this is your cube of sugar and this is your water. So you have the sugar completely dissolved into the core of the water molecule. In that case, it is absorption. Now remember that we have used the term adsorbent and adsorbent, and that is what we'll be using throughout the process. Do not forget that adsorbent is what you introduce, while the adsorbent is what receives that which you introduce. Now that is adsorption for you. Now, what is adsorption isotherm? An isotherm is simply a graph. All right, it's simply a graph that relates the amount of adsorbent, okay, that is absorbed on the adsorbent. I thought we're going to be using these two words. So when we say adsorption isotherm, it's simply a graph that portrays the amount of what adsorbent that is what dissolved in the adsorbent at a varied pressure but at a constant temperature. Always remember these terms, they are very important. What is adsorption isotherm? It is simply what a graph or a plot that relates the amount of adsorbent that does what is dissolved in what? In an adsorbent at a varied pressure but at a constant temperature. Now, if we now understand what that means, what is the Langmuir adsorption isotherm? I want us to know that the Langmuir adsorption isotherm simply explains the equilibrium that exists between a gas, okay, which is now your adsorbent, and a solid surface, which could be anything, which now is your adsorbent, okay, and the amount of gas, which is your adsorbent, that do what? Absorbed on the solid surface. So that is it. So when you say Langmuir adsorption isotherm, is simply describing the equilibrium between a gas, which is your adsorbent, and what? A solid surface, which is what? Your adsorbent. And the amount of the adsorbent, which is the gas, that ends up dissolving on the adsorbent. Now, that is what we mean. Now, we have been able to talk about what adsorption is, what adsorption isotherm is, and what Langmuir adsorption isotherm is. But there is something very striking about the Langmuir adsorption isotherm, and that is the assumptions of the Langmuir adsorption isotherm. Now, there are some assumptions that the Langmuir adsorption isotherm brings to us. Just like you have the Freundlich adsorption isotherm, the Betz adsorption isotherm, you also have the Freundlich adsorption isotherm. So many of them, the El-Awadi adsorption isotherm, there are so many of them. They have their assumptions. But the Langmuir adsorption isotherm is quite important. Now, there are some assumptions that it made, and one of the assumptions of the Langmuir adsorption isotherm is this. Now, the first assumption of the Langmuir adsorption isotherm is that the adsorbed molecules, or adsorption generally, is a monolayer process. Okay, that's what he said. He said adsorption is a monolayer process. It's a monolayer process. That is the first assumption of the Langmuir adsorption isotherm. Adsorption of molecules on the adsorbent, or the adsorbent, is what? Is a monolayer process. That is, adsorption is layer per layer, single layer to single layer. Now, the second assumption of this particular Langmuir adsorption isotherm is that the surface of the adsorbent that's supposed to receive is always flat and homogeneous. So it says the adsorbent surface is flat and homogeneous. Is flat and homogeneous. Now, this is just a summary of it. They're quite lengthy, but once you grab this, it's okay. Now, the adsorbent surface is flat and homogeneous. That is to say, that surface that receives, for example, water that receives kerosene, that is always a flat surface and it is homogeneous. That means it's not heterogeneous. So, it does not have separations. So, the surface is flat and it is what? Homogeneous all through, descent all through. Now, the third part of it is that the adsorbent, okay, will only do what? Will only accept one molecule at a time. So it says the absorbent absorbs one molecule only at a time. So it does not absorb more than one molecule at a time. And because of that, another assumption is that there is no interaction between absorbed molecules. There is no interaction between absorbed molecules. And finally, the final assumption is that the gas which is your absorbent is always an ideal gas. Okay, that the adsorbent is an ideal gas. Those are the assumptions. Those are actually the assumptions of what? Of the Langmuir adsorption isotherm. That adsorption is a monolayer process, that absorbent surfaces are flat and homogeneous, that absorbent absorbs one molecule at a time, there is no interaction between molecules, and the adsorbent is an ideal gas. Now, how do we derive the Langmuir adsorption isotherm? We are going to derive it. It's quite a very simple thing, quite short process. So how do we derive it? Now join me, let's derive this. Let's derive the Langmuir adsorption isotherm equation. Let's derive the Langmuir adsorption equation isotherm. But before we derive it, it's important for us to know that there are some specific parameters we must have in mind before we derive the Langmuir equation. Now, one is that we must know that there is a parameter like this, where we have 1 minus theta. And this parameter simply explains what? Explains number of what? Number of sites in the absorbent. Number of sites in the absorbent. We must know that. You must have this in your mind. And the second thing you have to know is this theta sign. This is simply number of sites in the adsorbent. And then you must also know that there is pressure. Remember that we said constant pressure. We said pressure is varied. Then you must also know that there is an equilibrium constant. Equilibrium constant. They are all gotten from the definitions we had made earlier. Now this equilibrium constant can be for both the absorption and the desorption. Now another one you need to know again that we have is N, which is number of active sites. Now if you are able to know these 5 things, then you can be able to derive the Langmuir adsorption isotherm equation that you can use to plot, to calculate, and also make plots, okay, to obtain the various parameters. Now, if we know that we have this, we can put them now into an equation that will allow us to do what? To derive that. Now, we are going to put this into equation to allow us to derive that. Now, this is what will happen. I want us to know that there are 2 equations that we must consider. The first one is the rate of adsorption, and the next one is the rate of desorption. That is because in the Langmuir adsorption isotherm, the rate of adsorption is equal to the rate of desorption. So which one is the rate of adsorption equation? So we will say rate of adsorption is defined as K of adsorption, P of adsorption, N, and 1 minus theta. Did you see that we use the parameters that I had listed to arrive here? So we have equilibrium constant of adsorption, we have pressure of adsorption, we have number of active sites, and we have the number of sites of the adsorbent. That is what the material that receives. Now the next one is rate of desorption. Since we say rate of adsorption is equal to rate of desorption, so we have Kd for equilibrium constant of desorption, and then we have number of active sites, and we have the number of what? Number of sites at the adsorbent. Now we can equate this. Since we say the rate of adsorption is equals to the rate of desorption. Since we say that, that means we can put this and this together. So by doing so, it means that equation 1 and 2 will be equated. So we have Ka PAN 1 minus theta is equals to Kd n theta. You see, we equate this and this because we had said that rate of adsorption is equal to rate of what? Desorption. So we equate this and this. Now when we equate this n can go away with this, do away with that. So what we will now have will be Ka Pa 1 minus theta is equal to Kd theta. That's what we'll have. And when we arrive here, it is easy for us to know that this is equilibrium constant of adsorption and equilibrium constant of desorption. We can just make it one equilibrium constant because it's talking about the same thing. So we will say, but K is equal to Ka over Kd. So it means that we will be using only this K. We won't be using these two any longer. So that implies that we will have what? K Pa 1 minus theta is equals to what? Theta. So simple. Now this is what we are going to be having. Now when we arrive here, we will collect like terms. We will send the theta factors to the right. So to send the theta factor to the right, so we send the theta factor to the right, that means we move this theta factor to the right. So we now have what? We now have Kpa is equals to theta all over what? 1 minus theta. Remember that this is, we are simply making this the storage of the formula. But what we are looking for is the theta, which is inside there, that has to do with the adsorbent, the material that is accepting. So in that case, we are going to put an invert. We are going to put an inversion. Okay? So we have 1 over what? Kpa is equals to, we'll turn this because we have put 1 all over here. We invert this. So 1 minus theta all over what? Theta. You see? I want us to know that this equation that we have here, this equation can be rewritten as 1 over theta minus theta over theta. Yes, we can calculate this is the same thing. So this can cancel this, and this will give you 1 over theta minus 1. So it means that we'll have 1 over Kpa is equals to what? 1 over theta minus 1. That's what we'll have. And when we get here, what we do next is what? We are looking for this. So we are looking for this, making the restoration of the formula. So we return this to this side. We will now have what? We will now have 1 over Kpa plus 1 is equals to 1 over theta. That's what we have. At this point, we can remove what? See, this equation that you have here can be rewritten. This equation you have here can be rewritten. You can have this equation, it's simply fraction. Okay? So this equation can also, see, it can be written as 1 plus kPa all over kPa. I do not want to bother us with it's just simply this. It's just to put kPa under here and then make a sort of formula, because you know that kPa will divide by kPa and then you have 1. Then you have kPa will divide by nothing and then times 1 you have kPa. So I have 1 plus kPa over what kPa. So this is what you have. And this equation will now equate with this. Okay? So we can now say that 1 over theta is equals to 1 plus kPa all over kPa. Okay? And when we remove this invert, so if you remove now the inversion, you will now have theta is equals to what? kPa all over 1 plus kPa. Now, that is your equation 11. Now, this equation you have here is now your Langmuir adsorption isotherm equation. Your Langmuir adsorption isotherm equation. Look at it here. This equation you have now is your Langmuir adsorption isotherm equation. You can see how simple it is to derive these equations that we have here. I'm sure that today you have learned something very interesting under surface and colloid chemistry, Langmuir adsorption isotherm, and how its assumptions and how it is being derived. You have also learned something concerning adsorption and absorption. Now, there I will leave you to the next class we're going to have again. We'll discuss further on other type of adsorption isotherm and every other thing that borders on surface and colloid chemistry. Until then, do not forget to subscribe Dr. B Chemistry Classes in my YouTube channel. Don't forget also to follow Dr. B Chemistry Classes in my Facebook page. Don't forget to make your comments in form of questions or otherwise will be attended to. Do not also forget to like and to share. Until then, it is bye for now.